Now, after exercise 1 in sets, next topic is empty set. The empty set. Okay, the empty set. The empty set. Clearly, in the word only, you have the meaning of this topic. Empty set means the set which is having no elements. The set which is having no elements. The set which is having no elements. No elements. See here, you have to observe for one thing. That is, suppose how we can write that empty set. That I will tell you. For example, here given that suppose you are studying 11th class. You're studying 11th class, and one more student studying 12th class. This is student 1, student 2. The student 1 cannot study at a time 1 and 2, I mean 11 and 12. And student 2 cannot study at a time 11 and 12. And if you take the student, set A is equal to X, such that X is a student studying both 8th and 9th classes. A is a set of students. What is how is that student is studying both 8th class and 9th class? So no one student can study at a time 8th and 9th class, not only 8th and 9th, 11th and 12th, whatever it is, no student will study at a time 2 classes. So then, is there any student exist? No, no student will study. Why? Because no student will study that. Already we know every student can study only one for year one class. 11th one year, 12th 1 year, and like the 13th 1 year, I mean degree, and 7th 1 year, 8th 1 year, like that. Every student can study for 1 year one class only. But here what I'm taking the set of students, what they are doing studying, what they are studying 8th and 9th class. 8th and 9th class, how the student will read, I mean will study 8th and 9th class at a time? So no students can study 8th and 9th class at a time. So this is an empty set. No student. This is an empty set. And empty set denoted by like this flower bracket without writing anything in this flower brackets. This is also denoting by empty set. And also we can write in empty set there is no elements. We can denote with pi. This is the name pi. Okay, already I think you know this pi meaning empty set. This meaning also empty set. Empty set means no elements, no objects, no students. So nothing is there in that set. That is only called empty set. Okay, and here we have some examples and definition. I think you can easily uh, write yourself. The definition is what a set does not contains. A set does not contains any element is called the empty set or the null set. Empty set or null set. Null set. One more name also there. What? Void set. Void set. See, the meaning of these three is same. That is what? Empty set. The set which is having no elements. Okay, and I'm giving you some examples. That is one. I gave you already that, and I'm giving one more that is in roster form. I mean, set builder form. That is set A is X such that here we have already 1 less than X less than The position of x is what? Lies between 1 and 2. And what is x is saying? X is a natural number. X is a natural number. So is there exist any value for x with this interval? See, 1 less than x less than 2. After 1, the natural number is 2, but he is saying what? Less than 2. And he is saying what? Greater than 1. So there is no value. After 1 means the greater than value for 1 is clearly 2, and the less than value for 2 is clearly 1. But he is saying between 1 and 2, not 1, not 2. Is there any natural number? That is the value of x, he is saying. But there is no any natural number for x between 1 and 2. So this is also an empty set. And one more example we have, that is b is equal to x such that x square minus 2 equal to 0, where x is a rational number. Rational number. Rational number. See, x square minus 2 is equal to 0 means you can write like this: x square is equal to 2. Then x is equal to plus or minus root 2 you will get. See how you can get a rational number of x. So there you will not get any rational number which is satisfying the equation to get 0. So if you substitute 1 2 3 4 like that, you will not get 0. Minus values will not get 0, and 0 if you substitute, you will not get 0. If you substitute a rational number, then you will get 0. But he's saying what? Rational number. The x is what? Rational number. So rational number is wrong. No rational number exists to get 0 for this equation. No rational number is root for this equation. So this is also an empty set. And one more example also here given, that is c equal to x such that x such that x is an prime is a sorry is an even prime number. Even prime number, pn, even prime number, which is even prime number which is greater than 2, which is greater than 2. See, we have prime numbers 2 3 5 7 so on. He's saying what? The set of values x, what? Greater than 2. But condition is what? Even prime number. Condition is what? Even prime number. We have only one even prime number, that is 2. Is 2 is even prime number, but he is asking what? Greater than 2. What are the prime numbers? He is asking. We have only one prime number. Even prime number, we have only one, that is 2. But he is asking greater than 2. So this is also not exist. So here also we have no any even prime number which is greater than 2. So no elements. So empty set or null set or void set. So it should be very perfect. Remember, I told you that already you will get 100%, not only 100%, you will get more than 100% questions for objective exam also. Remember, this is okay. Now, so like this, we can give more examples. One more also there. Fourth example, I'm not giving. You can understand that one also. And finite and infinite sets. Now we have to discuss about finite and infinite sets. Finite sets. So finite, infinite. How we can describe the definition finite, infinite? Okay, suppose if you take a set A is equal to set A, I'm writing all weekdays. I mean Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this is Sunday, this is Saturday, this is Tuesday, this is Thursday. Okay, don't think like that ss repeated, tt repeated. Okay, so how many days we have here? 7 days, which are countable, which are countable. Then that is called finite. Finite means we can count. Okay, infinite means we can't count. So here Sunday 1 2 3 4 5 6 7, so 7 days we have. So 7 is a countable number, which is we can say finite. So set A is a finite set, and set B also I'm writing alphabets. Alphabets in English. In English. So is this countable or not? This is also countable. We have how many alphabets in English? 26 alphabets. That is also, we can say what? Finite set. Then what about infinite set? Can you give any example infinite set, Harshita?
Um, like, yeah, normal ones only, right? You can write
You can
anything.
your own.
No, like anything is fine, right? Like just one, two, three, four, something.
I am asking infinite. I'm asking. Can you give me one example for infinite?
Okay, like natural numbers.
Very good. Natural numbers. What are the natural numbers? 1, 2, 3, 4, so on. So we can't count how many natural numbers. We have natural numbers up to infinity. We can't count that infinity. That is infinite sets. Infinite sets. But this is only not the solution. Suppose if given A is equal to 1, 2, 3, 4, 5, 6, 7, 8. So this is clearly, we can say, finite set. Then there will be rise one question, that is how we are saying that is finite set. Why? Because we can count the elements, objects, numbers, whatever it is which is having in this set. So how many elements we have here? 8. Then only we can say that is finite set. Then how we will write that this set having some numbers, some elements, some objects, that is n of a, number of elements in set A. N of a means number of elements or objects or whatever it is, elements, number of elements in set A. In set A. Now how many elements we have here? 8. So we can write like n of A is equal to 8, which is countable. Then we can say this is a finite. This is a finite set. And just now you told me that set B is equal to set C, right? Set C is equal to natural numbers 1, 2, 3, 4, 5, so on. So can we count how many we have? We can't count. Why? Because these up to infinity we have. So number of C, number of elements in the set natural numbers, which is some finite, but we can take as infinite. Fine. This is example for infinite set. This is example for finite set. We can take one more example. More examples we can take. Number of stars. So how many stars we have in sky? We can't count. That is also infinite set. Okay. I mean number of sand, infinite set. Water drops, infinite set. Like this we can take. We have more examples for infinite sets, and we have more examples for finite sets. Finite set means we should count the numbers, then only we can say that is finite set. Infinite means we can't count the number of elements. And how we will write n of whatever it is set given, n of A or n of B or n of C or n of D, whatever it is, n of P or Q, whatever it is. So here also n of. So number of, n of means number of elements in C, set C. Number of elements in set A, number of elements in set B. Like that we have to write, that is n of A, n of B, and n of C, so on. Just a second. Yeah, the set which is empty. This is also very, very important. Suppose in previous, I mean in just now we discuss about, yeah, here x square minus 2, right? I'm taking one example, just wait. Even prime number. Here we wrote one in previous page, that is a is equal to x such that x is an even prime number greater than 2. See, there is no x value which is greater than 2 which is even prime number. We know that, and we can say this is clearly empty set. Is empty set finite or infinite? I'm asking that. Is empty set finite or infinite? Can you tell me, Arshita? Is empty set finite or infinite? Or is there any option? What?
But it doesn't have anything, right?
Yeah, there is no element. I'm saying this is clearly empty set. Example, this is empty set example. Just now I gave you. Is this finite or infinite?
I think it's infinite.
Finite. Yes. Infinite set. We have just now discussed about finite and infinite. Once again, I'm giving you, see, finite set means we can count. We can count how many elements are there in the set. Infinite set means we can't count. We can't count how many elements are there in that set. Here, there, here I given a set which is empty set. Empty set means, suppose, listen carefully, Harjita. Suppose set A I'm taking 3 comma 7. Then how we can write n of A? N of A is what?
2.
What I'm saying, number of elements we should count, I'm saying, right? In empty set, is there any element? Hello?
No, no, sir.
Just be on unmute, just to follow. And
Yeah.
I'm taking one more set. B is equal to A, E, I, O, U. Then n of B is equal to what?
Uh,
Ovals.
5, 5.
5, right? Now I'm taking one more set. Listen carefully. C is equal to 1,50,000. Then n of C is what?
1.
1. Sure.
Yeah.
Then I'm taking one more set. D is equal to, like this. How many elements is there?
Uh, yeah, 0.
0. You are counting, na? Then we can write n of D is equal to what? 0. So nothing, no element is there. Then we can write n of D is equal to 0. Then we are counting as 0 element set, 0 element set, or null set, or void set. So we can say this is also a finite set. A finite set. So conclusion is what, every empty set is also a finite set. Every empty set is also a finite set. Okay, understand?
Yes, sir.
Yeah, here we have more examples for infinite sets. See, natural numbers
Whole
and
numbers, integers.
whole numbers and odd numbers, odd numbers, even numbers, even numbers, and real numbers, real numbers. Can you tell me what are real numbers?
Everything, like all the integers and like fractions and decimals.
Negative and positive also. So
Yeah,
tell me,
positive.
is that finite or infinite? Okay, finite or infinite. The basic is very important. Okay, don't take as easy. Okay, na. Let P is a set. P is a set of points on a straight line. Straight line. Is this finite or infinite?
Infinite.
Finite. Why? Because on every line there exist infinite points.
Yeah.
Points. Why? Because no ending. The line has having no ending, na, and no
Yeah.
starting, na. That's why there exist infinitely many points on every line, on every curve. Okay, so this is example for infinite, infinite,
Yeah.
infinite set. And one more, let S be the set of solutions. S is a set of solutions of a quadratic equation. A quadratic equation. S be the
Okay.
set of solutions of a quadratic equation. Is this finite or infinite?
Uh, it'll be finite, but depends on the equation, right?
Yeah, yeah. Just now, see, for example, ax squared plus bx plus c equal to 0. If I gave you, how
Yeah,
many
that's
roots there? Two roots only, na?
yeah.
Quadratic equation, right? So we can take this as example for finite set. Here given the equation x square minus what is the equation given here? X square minus 16 equal to 0. This is given in the book. So x square minus 16 means plus or minus 4 answer, right? And minus 4 comma 4 are the solution set. Next. So I think you understood about finite and infinite. Okay. Okay.
Yes, sir. Yeah.
Yeah, one more.
Okay.
Set set I'm writing a set builder form. A is equal to x such that x belongs to n and x is prime number. X is prime number. Finite or infinite? Finite or infinite?
Infinite.
Infinite. Why? Because what? Prime numbers, not condition. A condition is not given. Less than 2, greater than 2, like that. The condition is not given. Okay, that's why this is clearly prime number. Fine, infinite set. Okay, here one note is there. That is, note is, we know about roster form and set builder form. I told you roster form also should be count. Remember this, and should be in a same pattern like alphabets, ovals, numbers, weekdays, like that. You should have a set form. I mean, you should write in flower bracket form. Okay, not like this. You should, when you see the question, you can count like that. You should have a question like I gave you already. A is equal to a, e, I, o, u. Okay, see, this is clearly which form. This is roster form or not? Is this roster form or not?
Yeah, it's roster form.
Yeah, roster form. Is this roster form or not?
No,
No, this is which form?
set builder form.
Set builder form. This we can take example for finite or infinite.
Finite.
Finite. This
Infinite.
infinite. So the conclusion is what you know. We can't write infinite set in roster form. Remember that. Infinite set in roster form. Infinite set we can write into set builder form. That's why till now, if we take examples, we are writing always in set builder form or with 3 dots. Okay, so infinite sets. This is infinite. Infinite sets can't write into roster form. Roster form. Remember this. We can write infinite sets into set builder form. We can write infinite sets into set builder form. That is also one important node that is. Okay, remember that. And next, the last topic for this class, that is equal sets. Equal sets. After this, you have exercise. Equal sets means this is also very easy in the word you have the meaning of this topic. Equal sets means the sets should be equal. And when we can say the sets are equal, suppose if you take A is equal to, set A is equal to 1, 1, 2, 3, 4, 4. And I'm taking one more set B is equal to 1, 2, 3, 4. And one more set I'm say taking C is equal to 3, 1, 2, 4. So here clearly the number of elements, I mean n of A is equal to 1, 2, 3, 4, 5, 6. And here n of A is equal to 4. And here n of A is equal to also 4. But if you observe, the order is not for this. And here the numbers 1 and 4 are repeated. Here no number is repeated. But here these two sets, if you compare, 4 elements we have, but the order is different. This is 1, 2, 3, 4. This is 3, 1, 2, 4. This 1, 2, 3, 4 or 3, 1, 2, 4 we have here, but 1 is 2 times, 4 is 2 times. Here for equal sets, this is not important. Number of elements is not important. I mean, how many elements greater than or less than not important, but the numbers which are having in 3, 4, 5, how many sets if you take, the number should be same. 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. And here no need, if the numbers are repeated twice, thrice, 4 times, 5 times, whatever it is. That is actually how we will get. And I think you have doubt like how we will get 1, 1, 2, 2, 3, 3, 4, 4 like that, sir. That is depending on question we will get. In further classes we will discuss like this. You will get the answer like this: 1 2 times, 3 times, 2 and 3 times, and 4 2 times, like that you will get for some questions the solution. Okay, I will give you in further and in further classes. But here the concept for equal sets is, then the elements of every set should be equal, should be same, sorry, not equal, should be same. And if the elements are repeated, I mean same elements are repeated in any set, no problem. That is no problem for equal sets. So conclusion is what? The elements should be same. Elements should be same, should be same in all sets, in all sets. Second one, if any element repeated, no problem, no problem. I told you we can write mathematics in our own language, in our own style. Why? Because the concept what, how much we are understanding is important. How much you are writing is not important in maths. If you understand, you can write, not you can write in your own words, not only like this. Okay, the concept is what, for equal sets element should be same in every set. How many sets if you take, no problem. And if any element repeated also, no problem, like this 1 1 4 4. Then I'm writing A is equal to 1 2 3 5. B is equal to 2 2 1 5 3. Therefore we can write A equal to B. We can write A equal to B. We can say in other words also that what, the elements which are having in set A should be elements in set B. Should be elements in set B. This also we can write. The element which is from A should be in B. I mean, A and B are sets. Then also we can say A and B are equal sets, and we denote and we write like this: A equal to B. If any one of the element, for example, A is equal to A 1, 2, 3, 4, and B is equal to 1, 2, 3, 4. See, clearly this A is not there in this set B. Therefore, we can say A not equal to B. Means we can say A and B are unequal sets. Equal sets. Equal sets. Unequal. Unequal sets. Unequal sets. Equal sets and unequal sets. Equal sets means the elements which are having in set A should be in set B. Then we can say A and B are equal sets. The elements, any one of element, at least one element is enough. Your A is not there in B, then we can say A and B are not equal set. If there is no element in A, then we can say these two are clearly equal sets. So we denote, we write like A not equal to B for unequal, A equal to B for equal sets. Okay, na? 1 minute. Yeah, here we have example problem also.
హలో
And I'm hello.
హలో అన్న ఇంకా 3 minutes ఉన్నాయి.
Okay, okay, okay. Right, right. Harshita,
Yes, sir.
if in case for 40 minutes, if this will disconnect, then I will send you immediately one more link. Join with that link for 20 minutes. Okay.
Sir.
Okay, na?
Yeah, okay.
Right, right. And if I complete this topic now, then I will not send you. Okay.
Okay, sir. Okay.
Yeah. Example 7 is clearly homework for you. I think you have PDF now. You can see example 7. If you solve every problem, I mean already their solution you have. If you understand, there you have 1, 2, 3, 4, 5 sets given. 5 sets given, and is asking what tell me how many pair of equal sets. Is asking how many pair of equal sets. A, B, C, D, E. 5 sets given. Is asking how many pair of equal sets there in this question. A, B, B, C, C, D, A, B, C, D, whatever it is. Is asking what, how many pair of equal sets there in this exercise, example 7 question. So you have to solve their already given solutions, and the concept you have to understand. That is important. And if you have any doubt, you can send me pic. I will send you the solution. And example 8th. Example 8th is what? Writing here. Example 8 is what? Which of the following pairs of sets are equal? You are also given 2 pairs. Justify your answer. First question. What is the first question? Capital X is a set. The set of letters. Of letters. Some questions we can say by seeing the question answer. Of letters in A, L, L, O, Y. X is the set of letters in the word A, L, L, O, Y, and B is the set of letters in L, O, Y, A, L. L, O, Y, A, L. The first word A, L, L, O, Y. A, L, L, O, Y. Second word L, O, Y, A, L. I'm writing X is equal to A, comma L, comma L, comma O, comma Y. And the set B is equal to, they're given L, comma O, comma Y, comma A, comma L. See, number of elements is not important, I told you, for equal